You've probably heard that certain elements are very difficult to find, or some of them could be very rare, that when we do encounter them, it's kind of a big deal. Well, the good news is we can actually interact metals with different ionic substances in what we call a single replacement reaction. In a single replacement reaction, a metal reacts with some sort of compound, and when the two react, what ends up happening is a new metal is formed and a new ionic compound is formed. So let's take a look at two examples of how that happens. For this experiment, we are going to use copper 2 chloride. You may also use copper 2 nitrate. And then we are going to be using two different metals today. We're going to be using aluminum and tin. We do have an aluminum block here, but we can also use regular aluminum foil. I'm going to lay out both substances in these two small bowls. I also have a filtration set up on the side just in case I want to take this a step further after the reaction has occurred. Let's get started. So first we're going to place each metal in each cup, in each bowl, and then we are going to pour a little bit of this copper 2 chloride on our metals. So now we're going to interact the copper 2 chloride with both of our metals. And so notice how as I'm dropping copper 2 chloride on my aluminum block, we start to see some fizzing occurring. We're going to let this sit. Now we're going to observe what happens when we mix the copper 2 chloride with tin. For both setups, you want to make sure that you have enough of the copper 2 chloride to submerge both blocks in it. This will allow you to see the interactions happening between the copper 2 chloride and each of the metals. So what happens if you don't have access to metal blocks laying around? Well, the good news is you can try this exact same experiment with aluminum foil. So while we're waiting on these reactions to proceed and finish, we are going to try it out on a smaller scale with aluminum foil. You can use small strips of aluminum, lay it on here, just keeping it out there. And then we do the exact same thing that we just did, but this time we should be able to see the interactions right away because we're using a thinner piece of aluminum. We're seeing some bubbles form here. So we have enough that can submerge the aluminum foil in the copper 2 chloride. We've been able to observe the reaction of copper 2 chloride with two different metals. We did get to see it on a smaller scale by using aluminum foil and the copper 2 chloride. So if we really want to see the copper that's been formed from the two being mixed together, we can filter the mixture out. So I'm going to obtain my filter paper, place it nicely over my funnel, and then pour that mixture through the funnel, and let's observe. While we're allowing this to filter out, I am going to set this aside. And let's talk about the interactions that are happening in our bowls. So this right here was the mixture of copper 2 chloride and tin. Notice how you can see small little pieces of copper that are in the mixture. So notice how originally this is the color of our copper 2 chloride. We are now seeing a green liquid that has formed. Well, really what that green liquid is actually tin chloride. So the tin metal has reacted with the chloride ion in the copper 2 chloride solution. This green compound that you're seeing here is actually tin 2 chloride. And then if I pick up my block here, you can actually see that there has been corrosion, and that corrosion that you're seeing there is actually the copper metal. I'm gonna set this back. Now let's take a look at this mixture right here. So this mixture has the aluminum block and the copper 2 chloride. The exact same reaction that's happening here. It's just this one we're using an aluminum block. We started with a blue looking substance, and now we've got this blue dark gray cloudy liquid that has formed. If I pick up what was the aluminum block, you'll see that you've got more copper around this block in comparison to tin. Let's take a look. Now, why is that, you may wonder? Well, the reason why we're seeing more copper on the aluminum block versus the tin block is because of the fact that aluminum is actually more reactive than tin. There is what we call an activity series of metals where it describes and organizes the reactivities of different metals. If you were to access this activity series, you will see that aluminum is actually higher up compared to tin. And so that is why we're seeing more of that formation. I'm gonna set this back down, set this to the side, and let's take a look at what's happened here with our filtration setup. So notice how you've got greenish clear looking liquid. Let's compare it to what we had before. Now, what we're seeing here is the filtrate from the aluminum that has reacted with the copper 2 chloride. So this liquid in this flask is actually what we call aluminum chloride. Now, if I were to take this piece of filter paper off my funnel, now we've got some sort of powder here, and this is actually copper solid. This is what the copper would look like if we use aluminum foil, and then this is what the copper would look like if we used an aluminum block. Thanks for tuning in on today's experiment. We'll catch you again here at Expulsion Science.